So like Tony mentioned, what we're going to talk about today is looking at the system, looking at all the items you really should look at before you get into right-sizing a battery bank, and then what batteries you need and what batteries for what system. So as we dive into it, a little bit of background Tony mentioned, but like I said, just almost a decade in working with renewable installers out there, helping them to right-fit the batteries. So some things we're going to go over. We've got about 5 bullet points here. Is going to be first steps, what to do before you even select the battery you're going to use. 6 simple ways to slash electricity loads. Talking about surge capacities and depth of discharge, what the target should be, where you'd like to find that sweet spot. Objective look, we're going to actually look at battery types, and then we're actually going to kind of pull back the curtain on the manufacturing operations and show you what we do differently when we build the batteries that sets us apart. So with that being said, we're going to start with something we probably don't do enough when we get into the system is, number one, how do we cut back energy consumption to begin with? Ideally, we want to find ways where we can find LED light fixtures. We want to be able to find where we have some type of if we have some phantom loads being put on these batteries, how do we put them to a light strip? How do we cut that off when we're not using it? Put timers on hot water heaters, things like that. So those are things we want to look at so we can draw the consumption down and get the battery banks that's going to give you the longevity you're looking for. There's some other tips on ways to reduce it. We're in a lot of different renewable publications. You look here, one of them by Mark Snyder, Snyder Electric, 4 ways to maximize the microgrid. He wrote that with John Connell. So those are things that you can look at. You can find us on many of the publications. Oversizing your battery bank. It's something you definitely want to look at because what you use today may be not what you're going to use in the future. So we want to look at where your consumptions are and plan to overbuild that battery bank. So number one, you have the power when you need it. Number two, when you limit your depth of discharges, you're able to add longevity to your products. And that's the goal here. We want to make our products to hit that sweet spot so we can get the expected life for your customers or yourself, that they feel like they're getting the value that you've been quoting to them. So getting more batteries is expensive. It's going to be more cost on the actual storage side. I think the biggest thing here is if you overbuild the battery types, what you're going to do is you're going to get a good reputation for your business. You're over-delivering for what you've quoted, and that's what the customer's real expectations are. So what type of battery is right for me? We know there's a lot of different technologies and chemistries out there, so I think ideally you want to look and say, okay, what fits my application? What direction do I need to go? And what's going to deliver the value to what the customer is looking for? So economically, we're looking at 50 to 90% cheaper than other technologies out there. Proven and dependable. If you were here at the 1:30 session, we had someone talking about how they made Crown batteries last for 24 years in an application. It's an incredible number. It's incredible life. There's a lot of things that you need to do with that, but I think at the end of the day, it's the things we do on the internals and on the consultative side, making sure you have right fitted the battery helps deliver that value. What we consider medium energy density, easy to maintain. So on the AGM side, it's very easy. Obviously, it's a maintenance-free type battery. On our flooded types, we do a lot of different things to help to reduce the maintenance. The efficiencies on the inside goes to the manufacturing processes, and then also the accessories we put on the outside of the battery can help with lowering maintenance cost, speeding up the process with watering kits, etc. The bottom two are very important. We're talking about a technology that's been around for a long time. It's very safe, it's very proven. We know what the batteries can, how they can perform. And at the end of it, I think what is very important to everybody here is they're 99% recyclable. So the materials that the battery is made up of can be processed down and reused into the renewable energy industry again. Very, very important that a lot of technologies can't say today. So kind of leading into that, other options. We're talking about some lithium technology products. So number one is going to be the cost. We're looking at about 4 times the cost of what you can get on the lead acid side. Much more expensive for the same power. Long-term testing, we don't know. I think it's a good way of looking at it. There's a lot of I guess you could say, data out there that's showing the technology for 10, for 15 years. But when you actually look at the companies that are putting this material out there, they haven't been around that long. So it's a lot of calculations, it's a lot of accelerated testing. It's things we just can't actually put in the real world that are going to be true, in fact. Bullet point number 3, yes, high energy density on this type, low maintenance. But I think the bottom 2 are very, very important too. When you look at that, it's increased concern about runaway. We're seeing that all over. There's a lot of areas where we've had catastrophes where we're having incidents, thermal incidents that people are talking about. That doesn't happen with lead acid technology batteries. And then at the bottom, we're talking about recyclability. How much of the raw materials inside those batteries can be reused? And the numbers are between 0 to 60% downcyclable. So on the manufacturing side, this is kind of where we want to open up the cover, show you what the batteries look like on the cell side. So what we're talking about here is heavy plates. So we're actually putting more material where we can put active mass onto that battery to store power. So the thicker the plates, the more power we can deliver to your system. What we've decided to do is move towards robotic assembly. What this does is it's able to deliver repeatable quality. It helps the products perform, helps them operate much more efficiently, and it helps to cut down on, essentially warranties in the field. We're able to catch anything that may or may not happen in the plant before it goes out the door. Very, very important here. Talking about the reverse osmosis we use, that's something that's an absolute must for us. And then at the end, really, it's just more active material delivering power. When we talk about active material, more means more power, right? So when you look at other lead companies that are 60 to 80%, or lead is 60 to 80% of the battery cost, and raw materials have skyrocketed since 2016. So what is the reaction? There's 2 different types. There's a lesser and there's a better. The lesser manufacturers are finding ways to pull material out of the product while performing to hit the initial cycles and initial capacities. What the better manufacturers are doing is putting more product into it, so we're able to deliver more each cycle and for a longer period of time. Those are the key drivers, what makes the batteries perform. And this is a difference. These are some robotics you see in our plant on the right, and these are on the left. It's something that was used 15, 20 years ago. So we've kind of led the charge on automation to help run our plant more efficiently. When we talk about it, these are some of the things that come in the result. I think the number 2 bullet point is where we want to talk about is the cast-on strap. We're putting more thickness in that strap. We're doing it in one solid burn to help with efficiency, help with the connections. That's really the biggest part that we want to touch on. There's a few other ones up there that we can talk about after this presentation, but the COS, cast-on strap, is an important process for us. Some of the final points, ISO certified to the 2015 certification. Automated system, you can see an image of how we actually fill the batteries. We actually use a geothermal well to cool the batteries from the inside out when we charge them. Speeds up the process and actually gives them a better form before they come out of our plant. Vision systems, you'll see those at every operation we have within the plant. And then we obviously spend time on training our people inside to make sure they know what to look for and they're able to catch things. So you won't find these tips in any brochure. For maximum lifespan and capacity, all batteries need a safety margin. So when we talk about a safety margin, I think the question comes is, how much of the batteries can you actually use on a daily basis? There's claims of 80 to 100%. We hear that a lot. It's a great marketing claim, but it's not exactly factual. The idea of backup power or off-grid power is we want to have 80% DOD means 20% storage left in the battery. So you can do that, but the problem is going to be there's going to be a reaction in longevity when you take them down. So what we like to do is we like to try and target a 50% depth of discharge when we have our batteries in a cyclable application. It's something we've done for a long time, and it's going to help improve the overall life of the products. So we'll talk a little bit about surge capacities as well. So there's a lot of claims about being able to maintain them. What we want to talk about is different chemistries. Some surges are as low as 102 amps. And when you're talking about a 1 kilowatt load, such as an air conditioner, really it can't go for more than 5 minutes. Okay, so that's something you want to definitely make a point to look at. And then obviously we've got some other low surge charge of 208 amps. which you'll be able to really exceed this, and you'll have to shed some of those loads off of the batteries. So at the end of the day, you've made your selection. You've decided what battery you want to go with. And I think the one thing that's very important to you is you want to make sure that you provide you with the printed specifications for charge capacities. If they refuse this, keep after it. This is data that you really have to have when you're right fitting your batteries with your battery bank. Especially with an upstart company, there's some really, really important things we want to talk about. Are you getting the batteries at the same plant as advertised? Is the system sized for 50% DOD? Is the warranty in writing? If not, this is something you want to get before you buy these batteries. Get the warranty in writing. Whatever you're recommending, we always recommend buying or picking a company that you trust. And I skipped one here, but if you are going to be going with a newer company startup, make sure you look at a third-party insurance policy in the event that they're not around when those batteries have issues down the field. Very, very important thing to look at. All right, so with these tips and strategies, your batteries will give you many, many years of dependable and hassle-free life.